We have been using similar triangles to find missing measures. Now we're going to look at how we can do an indirect measure using similar triangles. So your essential question is, how do I use similar triangles to find measures indirectly? Learning intention. I'm learning to find missing measures using similar triangles and indirect measurement. So you've got a warm-up question. Pause the video and see if you can find X and Y. Well, I do hope you tried to do it on your own. Let's match our pieces up. If we're looking at this, we know that 48 will match with 6. We also know that X will match with 5. So we're going to start with 48 over 6. And that will be equal to X over 5. 48 over 6, X over 5. The 48 and the X are on the same triangle. The 6 and the 5 are on the other triangle. The 48 and the 6 are in the same position. The X and the 5 are in the same position. So we multiply and then we divide. So it's going to start off 5 times 48. Divide it by 6. And you end up with 40. Okay, we're going to do the same thing again. We're going to start with that 48 over 6. Now this time, 48 and 64 are in the same position, or on the same triangle. Y and 6, Y and six are on the same triangle. And that should be over Y, not over 4. That doesn't make sense. I just didn't do my Y very good. Remember, we always start out multiplying. Multiply at that diagonal. Then divide. 64 times 6 divided by 48. And you get 8. Okay, any questions? Okay, so let's look at how we find missing links using indirect measurements. To estimate the height of the Unisphere, the world's largest globe, you can place a mirror on the ground and stand where you can see the top of the Unisphere in the mirror, as shown in the diagram. What is the height of the Unisphere? So do you want to go from triangle to triangle, or do you want to go from side to side? Okay, let's do side to side first. Okay, 5.6 over 4 is equal to, now 5.6 is the height of the young man. X will be the height of the Unisphere over 100. Now, if you're looking, 4 quarters make a dollar bill. So I'm taking 4 times 25 to get 100. So I could also take 5.6 times 25, and I get 140. And that would be feet. But if I want to do the multiplication, I take 100 times 5.6 divided by 4, and you get 140 that way too. So if you can see what your scalar is, what you're multiplying the number by to get the next one, you can multiply both of them by that number. If not, then do the math. So, the unisphere is about 140 feet tall. That would be something I'd like to go see. Okay, the surveyor used the map to find the distance across Lake Okeechobee. Find the distance. Well, number one, are the triangles even? Similar? Yes, because we've got parallel lines. We've got that angle that would be congruent to both of them. Angle A is congruent to both of them. You've got your corresponding angles that are congruent, so by angle, we know that everything is in the same ratio. So if I'm looking at the first triangle, do you want to do 32 over 14 or 14 over 32? Does not matter. 32 over 14. Okay, now, the 14 is your base, the x is your base. 14 and x are the bases. We need this whole distance. 32 plus 14. Because we're looking at the whole side, whole side, whole side, whole side. So 32 plus 14 would be 46. So in our calculator, we would take 46 times 14 divided by 32. If I didn't want to do any of the math in my head, I'd use parentheses. 32 plus 14, close my parentheses, times 14 divided by 32. And you get 20.125, that would be 20 1/8. And we're going to round it . So, the lake is about 20 miles across. If you have any questions, back the video up and watch it again. Okay, we've got another drawing. As shown in the drawing, Raymond used similar triangles to find the height of the pole. When he stood 6.5 feet from a small puddle, he could see the reflection of the top of the pole in the puddle. The puddle was 26 feet from the pole, and Raymond's eye level was 5.5 feet above the ground. How tall is the pole? Do you want to go from triangle to triangle or from side to side? We'll use side to side. So if this is x, x over 26 has got to be equal to, okay, x is the height. The height over here is 5.5. And the distance is 6.5. So we always multiply first and then divide. 26 times 5.5 divided by 6.5. You end up with 22. The flagpole. Is about 22 feet tall. Okay, we've got two more. It would be a good time to pause the video and see if you can draw the diagram for the next one and solve. If you can do that on your own, then you know that you've got the concept down. So, Krista works for a company that cuts down diseased palm trees before they fall and cause damage. She must determine the height of the palm tree. Krista is 5 feet tall and has measured her shadow to be 6 feet long. At the same time, she measured the tree's shadow to be 27 feet long. What is the height of the palm tree? So, she is 5 feet tall. Her shadow is 6 feet. The tree shadow is 27 feet. What is the height of the palm tree? So let's draw our little stick figures. I think I'll use green again, so I've got green for the palm tree. So here is Krista. She is 5 feet tall. Her shadow is 6 feet long. Now let's do my palm tree. Here's my palm tree. X is the height. The shadow is 27 feet. How do I set it up? Do I go from side to side, or do I go from tree to tree? Or tree to person? Okay, if I go from side to side, X over 27 is equal to, X is my height, 5 over 6. Or, I could do X over 5 is equal to 27 over 6. Both ways are correct. You're going to do it the way you see. In either case, you'll start with 27 times 5 divided by 6. And you end up with 22.5. So the palm tree is about 22.5 feet tall. 0.5 is 1/2. Okay, if you didn't try that one on your own, pause the video now for the last one. It's very similar to what we just did. So, to go from side to side would be X over 90 is equal to 54 over 36. To go from triangle to triangle, X over 54 is equal to 90 over 36. Either way, you're going to start out by multiplying 54 and 90 together and then dividing by 36. and you end up with 125. And that would be inches. Do we usually do things in inches? No, we usually do them in feet. So 125 inches is equal to how many feet? Well, I take 125 and I will be dividing it by 12 because there's 12 inches in 1 foot. So you take the total number of inches and divide it by 12. And we end up with 10.4. And it goes 1.666. Well, honestly, I would probably go ahead and round up to a half. And I would say the pole is about 22.5 feet tall. So, how do you know when you're successful? When you can find any missing measure using similar triangles and indirect measurement. Similar triangles. And indirect measurement.